What's up, Chasers? Severe season is in full swing, and we can see that as we're monitoring an active weather pattern that's going to bring severe risks to millions of people across the country. Stay tuned as we're going to tell you what's happening, where it's going to happen, and when it's going to occur.
So as we move into mid and late April, severe season will continue to ramp up and our pattern will continue to get very active. Our first threat that we're looking at is going to be for tomorrow, April 9th, as we have a bit of a slight risk here in the Kansas and southern Nebraska area. And our primary threats will be wind at a 15% risk, a 15% hatched hail risk, and a very conditional tornado threat, depending if storms can become surface-based and if there is enough shear in the atmosphere. This would likely occur more towards the late evening and overnight hours, so there could be a nocturnal threat. Moving into our day 3 outlook, we do have a slight marginal risk here, not really too concerned about it. We could see some strong to severe storms, with our main threats being wind and hail. Now moving into the future, we're going to see a huge trough eject out from the southwestern United States and move into the southern plains area. This will create a very big severe weather risk beginning on Saturday across most of the southern plains, which will impact millions of people. Beginning on Saturday on day 4, we have our main risk area in the West Texas area. We're not really sure of what the primary hazards will be yet, depending on the mesoscale conditions. As we get closer, we will know more. Moving into day 5, we'll see our risk area continue to progress eastward along with our dry line that will be set up here. Our dry line will be our main lifting mechanism for this event, and we will have a lot of pop-up storms occurring here with very strong shear, as we will see later on. Moving into days 6 and 7, we're going to see our very active weather pattern continue across the southern plains, as we will see consistent troughing over the southwestern U.S., bringing in more shortwave disturbances and continuing our severe threat throughout next week.
So looking at tomorrow, you'll see in Kansas we've got a large shortwave embedded in a very weak trough that is coming with a lot of surface and mid-level moisture. That's going to be kind of what's providing our best looks for tomorrow. And then as we continue through the forecast period, you'll see that a slight ridge does kind of take over for the central plains, but with it we have a very weak jet streak and some very strong short waves that get kind of sent in between that region. We'll see a lot of moisture being pumped in from a somewhat deep low sitting in the northern portions of the central plains. As we keep going, this trough to our west is going to keep pushing those short waves through, and you'll see a lot of that PVA giving us a chance as that jet streak strengthens. That's going to give us a lot of lifting mechanisms and really kind of drive this chance for severe weather all week, especially as that trough just continues pushing into the central plains.
We see the consistent troughing over the southwestern U.S. as well, with just shortwave after shortwave coming through. There's not really an end in sight with this, as long-range modeling has hinted at this continuing through late April, and our NAO phase is actually very supportive of this continuing as well, and we could even see an active May, but that is way further down the line, and we'll get to that when we get there.
So these troughs, there's kind of a lot coming through, but one of the big driving factors of what's going to be happening with our weather systems is going to be coming in the timing of these troughs. And we're going to kind of point this out in the ensembles, but there's not a lot of agreement in these troughs. All that we know is that they are there, but the changes in when they're coming is going to be vastly different.
Right, so you have a consistent signal for this continuing, but there are still a lot of questions about when and how intense it'll be and the overall position and orientation of it, and we'll show that here in a moment.
But yeah, even when you're looking at this outside just the severe weather aspect, we're still going to see a lot of those central plains showers and thunderstorms pretty scattered throughout the region, because you've got this short wave, you've got these constant lifting mechanisms, you've got this massive moisture pool, and really, I mean, that's first off going to limit some of the daytime heating, but even in the nighttime hours, that elevated convection is still going to be happening, with the potential for your low-level jet mixing in with that lifting mechanism, providing some shear, and just giving you some fuel for some of those smaller storms just keep coming through everywhere.
Right, and I think to add on, I think there's just so much synoptic forcing with acting as a lifting mechanism, as we see also southerly flow continuing to advect moisture into our southern and central plains area. It's a very active weather pattern that's probably going to continue. So now taking a look at our slight risk area for our Kansas and southern Nebraska area, we'll see some morning convection ongoing along with probably overcast skies, preventing our daytime heating from really taking effect, as we see our low pressure system off to our west developing and enhancing our pressure gradient, which will continue our southerly flow, advecting moisture into the area. As we move forward in time, we'll see this convection slowly dies off and may suck up some of the instability throughout the day, but we'll have some convective initiation beginning around the sunset area, continuing overnight, posing a nocturnal threat for large hail, damaging winds, and even a conditional tornado threat as our low-level jet kicks in.
Well, I mean, if you look at a lot of this too, you can see all the isobar kinking going on in there with the low pressure system. I mean, really, a lot of this threat's just going to be sitting in that warm sector of the low pressure system. So you're going to see a lot of just elevated K values, elevated instability. You know, with the higher surface temperatures, you're probably going to have a lot more moisture mixed into that region as the cold front will be kind of sitting to the south of it. So it's very much going to be an unstable air mass that's just going to fuel this threat to continue.
On the contrary of that, if you kind of look at where the isobars are kinking, a lot of what these are lifting off of is that cold front that's up in the Canada region, connecting with our low pressure to the west. And I think some of these storms are actually forming to the south of that front, and I think that's going to help us getting past some of these elevated values.
Because, I mean, looking through the sounding, right, you can see especially looking at that photograph, our speed shear is very weak. I mean, we're sitting at 30 knots for most of that column. We've got good directional shear for the lower portion of the atmosphere, which would be great for a tornado if we had some larger shear across the entire column to actually get that supercell going. But you can see our K values are kind of modest. We've got that adiabatic temperature from the surface going to about 725 millibars, where we'll likely see some clouds there. But, I mean, it's modest K values.
All right, so kind of looking as the week progresses, we can kind of see that cutoff low on the west coast coming into the US, and we can see just by that pressure gradient how deep that trough actually is, how deep that low is. That's going to bring a lot of forcing for thunderstorms and showers as it goes.
With the most active severe weather setups, we see a lot of short waves embedded inside of our very large upper level trough. And we'll see this, on Sunday, and we can see some potential short waves out ahead of this trough, bringing a potential for a localized area of higher vorticity values, which could increase our tornado threat shortly. And we'll see as this continues to progress, we have a lot of short waves out ahead of this. Obviously, this is one model run, and we'll take a look at what some of the other models have to say momentarily. But we can really see how far this trough digs in throughout the week, and this will just continue posing a severe weather threat for millions across the southern plains and the central plains throughout the week.
I mean, even as you progress through the time frame, you can see just within that little trough, a lot of mini shortwave troughs kind of get spit out of it, and that's what's going to be fueling this to come through for a long period of time. And even then, I mean, we've got this it's somewhat broad on the northern end, but on that southern end, that trough is kind of sitting there. That's a great place for development for a surface low that can start getting us a lot more forcing. I mean, as we look through our ensembles, especially for the start of the period, we're at least seeing a lot of agreements that, the features are going to happen. We'll see that broad ridge to the northeast. We'll see this trough moving in the southwest of the U.S. You'll see kind of that just large flow across in between. That's what's going to be feeding those short waves. And, I mean, the intensity is varying, but for the most part, it's looking like even throughout 138 forecast hour, and we're seeing a lot of just agreement within the trough, or within the ensembles. Is kind of impressive.
So building off of what Adam said, we can see that there is a signal in every ensemble member of just some big trough occurring across the western United States. But the location of it is still up in the air, as we can see across different ensemble members. We do have some spread on the intensity as well as the overall location of our trough as we keep looking through different members here. We do have a lot of uncertainty, but we know that something will happen at some point. But the overall threat and the specifics of it will become more refined as we get closer to the event. So now we're going to be taking a look at the more specific ingredients and where they might be with our severe weather pattern as we advance into the future. As we know, there's 3 ingredients required for precipitation to occur. moisture, lift, and instability, and if we want severe storms, we need vertical wind shear. So first, taking a look at our dew points as well as the location of our dry line. As we progress through time, we do continue to see that dry line persistent over the northwest Texas Panhandle and New Mexico area. And as we advance into the beginning of our significant severe weather period into Saturday, we can see that this dry line will continue to stay in place as we get a surge of moisture coming in off the Gulf with this low pressure forming up in the lee of the Rockies.
It's impressive right there, seeing dew points going into the Panhandle, into Western Texas, into New Mexico, hitting those lower 50s, and then that contour of the 60-degree plus, even upwards of 70, reaching as far north as Oklahoma, Kansas, Nebraska, Iowa, even.
I mean, it's just impressive how much moisture we're seeing in general. Like getting that far north, that's a lot.
Throughout this event, we're going to have our dry line be our main initiator of convection, as we see present here. This will act as our primary lifting mechanism throughout our event. And as we progress through time, we'll actually see this boundary continue to advance eastward, also shifting our threat eastward throughout the week, more into the eastern areas of Oklahoma, Missouri, and Arkansas, as well as Kansas. Mainly watching this area throughout the entire week, as we will see consistent lifting here. So as we continue to work through the rest of the week, we're going to see plentiful moisture across Texas and Oklahoma and Arkansas and all these other states as we continue to get advection off of the Gulf from the low pressure system. It's just very, very impressive values here. I mean, it's just one model run, but we're already seeing dew points in the low to mid 70s in some areas. It's just extraordinary.
Okay, so now that we've looked at the surface moisture, we can kind of take a look at the whole column. And the first thing that we notice on this is that low pressure system over Canada, and that's just a textbook Alberta clipper. You can see how strong that moist conveyor belt and the dry conveyor belt are both showing. But kind of as we go forward into this, we can start seeing that we're going to be advecting more moisture up further north as we go. And this is kind of showing that we don't just have those high dew points at the surface, rather we're going to see lots of moisture all the way up. So kind of we can see these values reaching over 1.4 all the way up into the Midwest, reaching above 1.6 in southeastern Texas. So we kind of see that across the whole column, we have lots of moisture and lots of fuel for these storms to kind of occur.
Right, and I think it's also really cool as we can see our cutoff flow here over the western United States, just interacting with our subtropical jet, just advecting so much moisture into the area. It's just incredible for this time of year to see that. Right, and something else I want to point out as well is our high pressure just sitting off over here, continuing to advect moisture as well. But what else the surface of the 400 millibar mean wind can also tell us is our general storm motion. As we can see here, as our short waves progress, we can't really see that on here, but as our short waves approach and pass through the area, we can see our storm motion pick up pretty rapidly up to almost 50 to 60 knots in some areas. This could pose for some very fast-moving tornadoes if they were to happen, which would be a very dangerous event. But generally, our storm motion can be expected to be about 30 to 35 knots across most of the risk area, with some upwards of 55 to 60 knots, depending on if the short wave is strong as modeled and will come in at the golden hour. Now, moving into the beginning of our significant weather period, beginning on Saturday, we're going to see these instability values continue to increase as we get warm air advection from the Gulf. And now looking at our western area across the Texas Panhandle, we can see some Cape values upwards of 1,000 to 1,500 joules. It is important to note that the GFS also does typically underdo Cape, so these values will likely be closer to 1,500 to 2,000 joules. So now taking a look at a photograph from our risk area on Saturday, it does appear that our main threat is going to be hail, along with some potential damaging winds. Our photograph isn't overly impressive as our shear values are relatively weak, but we do have some curvature in the low levels as well as decent SRH values. However, it is also important to note that our storms will also be dependent on if they can actually initiate or not. Looking at our low level lapse rate, we can see a slight, not quite a slight inversion, but we can see some weaker lapse rates, which could prevent storms from firing initially, but if we can overcome that, then we will see some action. Mostly probably going to be a large hail and damaging wind threat as our trough approaches.
I'm gonna kind of veer off of that a little bit. I'm gonna say it's mostly gonna be damaging winds. I think if any hail comes, it's gonna be shallow. I mean, we don't have enough robust cape, and we don't have enough shear to kind of keep that tail inside of the updraft, even if it can get going. So I think, I can still see hail happening. I don't see it being as big though as it could be in some of these other days.
Now, moving into Sunday, we're going to see our severe threat and instability ramp up tremendously. As we look throughout the day on Sunday, we can see our Cape values already increasing at 4 p.m., upwards of 2,500 joules in some areas. Now, if we pull a sounding from our risk area at 21Z, just before the main action will begin, we can see we do have our cap in place here with a slight inversion, and we do have a solid hodograph with very good shear at 46 knots from the surface upwards to 6 kilometer. We also do have very decent mid-level lapse rates, which would support hail formation.
I mean, just looking at this day alone, that cape is already so much deeper. It's much better, but I think a lot of it comes down to is, are we going to get mid-level moisture or any daytime heating enough just to make sure that we actually go past that cap right there, as a...
Because the two things I kind of see in this sounding is you see how saturated that is for most of the column. I mean, if we're stuck with clouds, that surface temperature is going to be slightly lower. And the other biggest thing is, like you said, that cap, it really needs to be eroded. Because, I mean, you look and, right, this convection line is made to simulate including your density from the moisture. But if you subtract even a little bit of that, you're going to hit that cap and you won't be able to break past it.
Right. It's just the biggest question with this setup is if storms will be able to initiate or not, depending on if we can get enough surface heating and be able to break through that cap. But as we can see, as we advance through time, that cap does erode slightly according to the GFS, and our Cape values do continue to be excellent northward of 2,000 joules. We also see our LCL being very low here, also supporting our potential for tornadoes as we have very good SRH values at the low levels.
We'll point out, though, that as we go on, though, even though we do see getting eroding of that cap, we also see a lot shallower cape as time goes on, too. So that also might play a factor in some of the...
to kind of tag along with that, I mean, we've also got that mid and upper level backing. I mean, once you get past about that 2 kilometer range, 3 kilometer range, you just start having that kind of opposite the way you want it. It's not ideal. You're going to see a lot of sinking motion in there.
So now kind of as we move further into the week, we saw that dry line is what's lifting a lot of these storms, and we see it pushing east, and with it pushing east, we see these high cape values also moving east, which is where our storm threats are going to go. And that kind of follows some of the risks that we outlined at the beginning of the video.
We can just see our continued instability just present across the southern plains. This is just going to continue to give us fuel for storms to continue to pop off and maybe be able to sustain themselves. So now moving into one of our biggest questions about the severe setup is the overall cloud cover and any morning convection that occurs. So first we're going to take a look at cloud cover, and as we can see across the country on Thursday and on our risk area continuing through Friday and Saturday, we see lots and lots of clouds throughout the area, which could limit our daytime heating, which would reduce our values of cape and instability across the area. But as we can see through Saturday, this continues just blanketed in clouds across the entire central and southern plains region. Whether we can get break in the clouds or not to allow for daytime heating for storms to initiate, that is a bigger question, but we will see some form of severe weather. That is a guarantee at this point. Now moving forward into Sunday, we can see continued cloud coverage just blanketing our entire risk area. And on moving into Tuesday now, we can see just continued cloud coverage after cloud coverage every single day. So it's just a matter of if we can get enough clearing or not for our daytime heating to be able to kick in. And most of the times we do see some break in the clouds during the late afternoon hours as the sunlight does erode the cloud away.
I do think this is going to play a large role in kind of what we see and how much convection is going to occur, because kind of what we can infer from this map, we know we have a lot of lifting mechanisms in place. We have all these troughs, all this divergence aloft, and we just kind of know that there's a lot of cloud cover there. And kind of when we went back to the soundings that we were looking at, we see the biggest problem in how much CAPE there was is we still had these warm noses. We still had these caps that were kind of almost blocking our convection, making everything elevated. So a lot of the chances for these storms to actually grow upscale and become bigger is really going to come down to how much the daytime heating can erode these clouds away and erode those caps away.
Right, and we can also see with our morning convection potential, which could neutralize and stabilize our atmosphere during the morning and early afternoon hours. We do see with our 6-hour QPF that we do have some rainfall accumulations through most of the risk area with some locally higher amounts with those severe storms. But we can see just generally we do just have a widespread area of just light accumulations throughout the morning and early afternoon hours before the main setup does begin. But we will see how much this morning convection does limit our overall severe threat, but I do think that there is enough instability to be able to overcome this, as we do see commonly in most severe setups across the severe season. That'll be all for today's video. As we can see, a very active weather pattern will be beginning and continuing through mid to late April as severe season ramps up. If you enjoyed this video, be sure to like, subscribe, and share this with your friends and family to alert them of the upcoming severe weather potential. Thank you all for watching, and we will have another video up later this week going more into detail about this weekend and next week's setup as more details come in.